Hello and welcome to a new video lesson. So by now, we are accustomed to the consumer side of the story, right? How they demand a particular product, how their demand shifts on the basis of other products, etc. Now, let us learn about the other side, that is from where we buy the product, that is the producers. Now, the commodities that we buy are carried out in the firms. So how does production work? A lot of us love pizzas. So how do we get a pizza when we want it? We go to the store, ask for it and pay for it. It seems like the store had a pizza ready for us. But what happens at the back end? Obviously, the pizza needs certain ingredients. The bread, the sauce, the vegetables, etc. Now the pizza store didn't make all these products obviously. They bought it from someone like you are buying the pizza. Thus, the products that the pizza store is buying is his inputs, and the products that he is producing is his output. Now obviously, these inputs didn't come for free. The pizza store also paid to the producers of wheat for bread, tomatoes, for sauce. Thus, the amounts that the pizza store is paying to the producer of wheat and tomato is the cost of production. Now, you are ordering a pizza and paying for it. So when you pay it, then this amount becomes the revenue for the pizza store. So the amount the store spends is the cost of production, and the amount you pay is the revenue for the store. Now the difference that might exist between the cost of production and the revenue is the profit. Now the wheat that is an input for the pizza store will also have some other inputs, right? Thus, let us move on to our assumptions for this chapter. For simplicity, we stick to the similar assumptions as your book. We assume that a farmer produces wheat. So, in his production, the two inputs are land and hours of labor. Like demand function, here also we have production function. If 3 hours of labor per day is used on 1 hectare of land produces 3 tons of wheat, then the production function is written as Q is equal to K into L equal to 3 into 1 equal to 3 tons of wheat. A production function always gives the maximum amount that can be produced by the given inputs. Thus, a generalized form of the production function would be Q is equal to F into LK, where Q is the maximum output produced. Here we assume that L and K are labor and capital respectively. Now, like that of the indifference curve, here also we can construct an isoquant. The isoquant here actually shows all points where labor and capital can be substituted. An isoquant gives all the possible combinations of the inputs that gives the maximum level of output. Now, more than one combination can produce same output, like what 1 labor and 4 capital can produce. 2 labor and 3 capital can also produce the same amount. Thus, both these combinations will lie on the same isoquant. Thus, like that of an indifference curve, all the points in an isoquant also produces the same level of output. Similarly, higher isoquant will mean higher level of production when the marginal products are positive. In production, another important concept which should be kept in mind is the long run and the short run. The terms long run and the short run are not defined in the same way in economics as it is in English. Here the long run or short run is not defined on the basis of the number of days, rather on the basis of variability of inputs. In our example, the farmer has 2 inputs, the land and the labor. In short run, any of these two inputs will remain constant or fixed. That is, the land may remain fixed and the labor varies. The input which remains fixed is known as the fixed factor. In this case, it is the land. The other input is known as the variable factor. Here, the labor is the variable factor, whereas in case of long run, all the factors of production, that is the land and the labor, are variables. Moving on, let us learn about some important tools of the chapter production. These are total product, average product, and marginal product. You will find that maximum sums from this segment of the chapter. Keeping one of the inputs constant and varying other inputs, let's find the total product curve. This relationship between the variable input and the output is known as the total product. For example, if we take the input of capital to be constant and increase the input labor, then the output at different levels of labor will be different. This is given by the total product of the labor. The shape of the TP curve depends on the law of diminishing returns on productivity and is an inverted U. According to the law of diminishing returns, the total product of a factor input initially rises, but after reaching a certain level of output, it starts falling. Now that we have understood total product, we can easily find out the average product and the marginal product. Since the curve for AP and MP is also same as AP, we will draw it on the same plane. Average product is the output per variable input. We get average product by dividing the total product. Therefore, APL is equal to TPL over L, whereas marginal product of an input is the change in output for per unit change in input. MPL, change in output over change in input, is equal to delta TPL over delta L. Here too, the AP and MP graphs demonstrate an inverted U shape because of the law of diminishing returns. This can be explained with the use of one simple line: too many cooks spoil the broth. So the marginal product for labor will keep on rising as long as each labor is able to reach its maximum efficiency. But after a while, too many workers are not able to produce a lot more because their efficiencies have already been maximized. Let's look at an example of how TP, AP, and MP changes. Here we have different values of L, TP, AP, and MP. In every step, as we calculate MP, we can see that at first, the MP value rises from 15 to 21 and then falls back to 15. L, TPL, APL, MPL, 0, 0, 0, 0. 1, 15, 15 over 1, which equals to 15. 15 minus 0 over 1 minus 0, which equals to 15. 2, 36. 36 over 2, which equals to 18. 36 minus 15 over 2 minus 1, which equals to 21. 3, 51. 51 over 3, which equals to 17. 51 minus 36 over 3 minus 2, which equals to 15. Friends, kindly note that with the increase in the amount of input, as MP rises, AP would also rise, since it is the average of the marginal products. But the rise in AP will always be lower than the rise in MP. As long as MP is greater than AP, the AP curve would continue to rise. But when, after a considerable fall, the value of MP is lower, then the AP curve will also start to fall. Notice that the AP curve cuts the MP curve when it is at its maximum. Now we all know that change in input results in some kind of change in the output. But till now, we have been keeping one of the input constant. But in the long run, both the inputs can change, right? Thus, when proportionate rise in all the inputs results in equal proportion rise in the output, the production function is said to be constant, returns to scale, or CRS. Whereas, when proportional rise in input results in more than proportional increase in the output, then it is known as the increasing returns to scale. Finally, when proportional rise in inputs leads to less than proportional increase in output, then it is known as the decreasing returns to scale. Look how we can show these with the isoquants. With IRS, the isoquants jumps from 100Q to 300Q, while with CRS, they show equal rise in amounts from 100Q to 200Q. With DRS, they show less than proportionate increases from 100Q to 150Q. With this, we have come to the end of the production part of this chapter. In our next video lesson, we'll be studying about the cost. Till then, keep watching Notebook.